Okay, today we are going to be doing Chapter 8, Lesson 1 and 2 together. Chapter 8, Lesson 1 is about squares and rectangles, and Lesson 2 is about parallelograms and triangles. What I want you to create for this is a Chapter 8 formula sheet, and so I want you to put all of the formulas on one clean sheet so that we're easy to be able to look back and forth and find them. So on this clean sheet of paper, I want you to pause and put down the area of a square and a rectangle. Now put down the area of a parallelogram and a triangle. Okay, so in this figure we have here, we have a shaded area of a figure, and it only wants the shaded area. So what we need to do is find the area of the entire outside of this figure, and then since the inside is white, we are going to subtract that out. So I have 9 times 9 for the outside, which is 81. I don't like that. And 7 times 7, which is 49. Then I'm going to subtract those out because I only want the inside of, or the shaded area. And 81 minus 49 gives me 32 feet squared. On the second one, I actually have two well, this is new. Okay. On this one, I actually have two different figures here that I need to split up. And so I'm going to split it, and I can split it either this way or this way. It doesn't matter which way I split it. And so I'm going to split it off to the side here. So I know that the height of this is 6, and I know that this entire length here is 10, and this much of it is 6, which leaves this much for 4. So this side is a 4 times 6, which is 24, and this other side is a 6 by 9.5, which is 57, and they are both shaded, so I'm going to add them together to get a total of 81 centimeters squared. This one I have a bunch of different ways I can split it off, but I'm going to split off these two sides here. So this side here is a 6 by 6.5, which is a 39. This side here is a 4 by 20 or 7, which is 28. And then this side, we know this much is 6.5. I know that the whole side is 7 and that this much of it is 5, so that leaves us with 2. So I have 6.5 by 2, which is 13. So I'm going to add 39 plus 13 plus 28 for a total of 80 meters squared. Okay, we're going to do the same thing here on this shaded area. So again, we can split it either way, but I'm going to split this section off, which I know this whole side is 12, and this much of it is 9, which leaves 3 on this side. So 4 times 3 is 12, plus 9 times 8 is 72, which gives me a total of 89 inches squared. In this exercise, they want us to draw the figure. So let me add graph paper. Okay, so we are going to graph this figure. Point A is at 0, 0. B is at -5, 0. C is at -5, -2.5. And D is at 0, -2.5. It wants me to do two things here. It wants me to find the perimeter, which remember from chapter 3 is found by adding up all the sides. So I'm going to do that first. So the length of this side is 5. The length of this side is 2.5. So I have 5 plus 2.5 plus 5 on the bottom and 2.5 on the left side. So my perimeter is 15. Then for the area, I'm going to do 5 times 2.5. So my area is 12.5. Number 6 says the area of a square backyard is 400. Well, if this is a square and we don't know what the length is, the width would also have to be x because x, a square has the same sides from chapter 5 definition of a square. So the area would be length times width, and x times x is x squared. We set that equal to the area, which they give us is 400. Now remember, to undo a squared, we take the square root, and the square root of 400 is 20. So I know if this side is 20, this side is 20, and it's a square. They're all 20. And it says find the perimeter. You find the perimeter by adding up all the sides. So when I add them all up, I get 80 feet. Number 7 says one conference in an office building measures 18 by 24. Another rectangular conference room has the same area, but its width is 16. What is the length? So we can solve this one two ways. We can either find the area of the first conference room and then divide it by 16 to find the area or the length of the other one, or we can set up in proportions. Since we're working with area today, I'm going to do it the first way. So I'm going to do 24 times 18 to get this area to be 432. And then when I do this area, it'd be 16x. So I'm going to divide 432 by 16, and I get the length to be 27 feet. Number 8 says a deck 4 feet wide surrounds a rectangular pool, and the pool is 20 by 15. Find the area of the deck. So here's my pool, which is 20 by 15, and it has a 4 foot wide deck that goes all the way around it. So this kind of turns in, it wants the area of the deck. So this kind of turns into a problem like number 1 here, where the deck is on the outside. And so what we need to do is find the area of the outside and subtract the area of the inside or the pool, because we do not want to put a deck around our pool. Now we know that the length of the pool here is 15, but I also have a deck here and a deck here, and they're 4 foot. So actually the total length on this one would be 21. Or it was 4 foot, not 3 foot. So 15 plus 8 gives me 23. Same thing here. I know the length of the pool is 20. However, it has a 4 foot deck on each side. So that would give me a total of 28. So again, I'm going to do the area of the whole thing, which is 644. And I need to subtract out the area of the pool because I do not want to put my deck in the pool, which is 300. And when I do 644 minus 300, I get 344 feet squared. Okay, now we're moving on to lesson 2, which is parallelograms and triangles. And this first one just wants me to do this parallelogram, which is a 6 by 11, which is 66 feet squared. This next one, I have to do half the base, which is 80, times the height, which is 73. And so I put that in and I get 2920 centimeters squared. This one is a parallelogram again, so just length times width. So 8 times 6 is 48. This one again is half the base times the height, which is 42. On this one, we actually have to split it because we haven't done formulas for a trapezoid yet. And so what I'm going to split it into is a triangle and a rectangle. Now this rectangle is 7 by 5.5. And 7 times 5.5 is 38.5. And if I know that this whole length is 9, but I've already used 7, that leaves this much with 2. And I know that the height is 5.5 because it's the same as this right side. And so I do half of 2 times 5.5 gives me 5.5. I'm going to add them together to find the total area to be 44, right? 38.5 plus 5.5. 44. This one, the important thing to know is that we're using the straight height. So this 3.7 is actually just extra information. So the base of the triangle is 9. So I do half the base, and then just make sure that I times it by the straight height, which gives me 31.5. This one, as confusing as it looks, is actually just a parallelogram. And so I'm going to use the height, which is 38, times the base, which is 80, is 3040. This one, you see we have a rectangle here, which is an 8 by 5, which is a 40. And we have two of these equal triangles, which the height is 4, or the base is 4 and the height is 5. So that would give me 10 on each side. So 10 plus 40 gives me a total of 60. In this Venn diagram, what they're trying to show you is that you can take a triangle that has a certain area and you can stretch it. But think of it like if you made a triangle out of Play-Doh, you can stretch that Play-Doh and it may look like a bigger triangle. However, you still have the same amount of Play-Doh. So if you look at all three of these triangles, which is GDH, GHE, and GFH, you notice they all have the same height. And since they're all going from G to H, they all actually have the same base. So they are all going to have the same formula, which is half of 8.2 times 4.5. So as long as you slide the vertex along a parallel line, it can stretch your triangle. But however, since it's within the parallel lines, the height is going to be the same. And so the areas are actually never going to change.